Suppose you want to derive, the following formula. P implies not P. So P implies the double negation. So if I say I'm walking in the park, well, if I'm walking in the park, then it is not the case that I'm not walking in the park. So that's what this formula means. So if you assert something, then you can also assert the double negation. So this formula is an implication. So it has an antecedent right here. That's P, what's on the left-hand side of the arrow. And then you have a consequent, not P, on the right-hand side of the arrow. So whenever you try to derive an implication, you need to assume the antecedent and try to derive the consequent. So I'm going to write this formula at the bottom here. So this is our goal. So I'm working backwards in constructing the derivation. So the derivation should arrive at this point. And as I said, since this has the form of an implication, the strategy to derive it should be assume P, so assume the antecedent, let's call this assumption 1, and then through various steps try to arrive at the consequent. And so by using the implication introduction rule, you should manage to derive the implication. And so always remember that the implication introduction rule has the following form. It says, so here's the implication introduction where it says if you assume A, through various steps you get to B, then you can say A implies B. That's the implication introduction where you can cancel the assumption A because you have incorporated it as the antecedent of your implication. So that's a rule that we're using. Now here we have not P. Now, whenever we have a negation, it's also important to use our notational convention. Notational convention NC, which says that whenever you have something like not A is the same as A implies the contradiction. So here I have a double negation. I have not P. It's important maybe to kind of be clear, put this not P between parentheses. So what I have here is not P. So our A here in this case is not P. So by using the notational convention, I can translate this not P in not P implies the contradiction. So I took one negation out. Just like the notational convention does, takes one negation out and puts it as implies the contradiction. So that's the same I did here. I took one negation out and I put it as implies the contradiction. I can repeat this process one more time because I have my I have another negation right here, but I can also wait. So if we are at this point, so this is again in the form of an implication. So one can see that that's in the form of an implication. And we know that when something is in the form of an implication, what we need to do is to assume the antecedent and try to derive the consequent in order to get that. So this is another assumption that I can make. So let me make it up here. So this is not P. So this is my assumption number 2. And then I can write the implication, the contradiction up here. And so I'm going to use again the rule of implication introduction. So presumably from this assumption number 2, not P, I should go down and get the contradiction. Now, how am I going to get from this assumption not P to the contradiction? Well, you can see that I have P and not P, so it should be pretty straightforward to get the contradiction. How do I do that? Well, first of all, note that not P is, by our notational convention, equivalent to say P, and P implies the contradiction. Now, once you see that, so I have P implies the contradiction, and then it becomes pretty straightforward by implication elimination to get to the contradiction. I have some white space here just simply because you know, I didn't know exactly how the derivation would go, so I put this assumption a little too further up, but it's no problem. So I got the contradiction, and essentially my derivation is done at this point. I've taken care of all the steps. So one thing I can do is just to check, especially what I should check is that my assumption that I made, so P, that's my assumption 1, and not P, that's my assumption 2, I should be able to cancel them. Okay, so I assume P, I assume not P, I got P implies the contradiction by our notational convention. I put these two things together, I got the contradiction. This is simply implication elimination. No problem there, it's like having A implies B, therefore B. So that's modus ponens. Now, since I've assumed not P up here, and I got to the contradiction, I can say not P implies the contradiction by the rule of implication introduction, which would be indexed to my assumption number 2. So I can cancel it because the assumption has become the antecedent of our implication, what comes to the left-hand side of the arrow. Now here I can use our notational convention. So since I have not P implies the contradiction, I can say, well, that's equivalent to say not P. Because remember that not A is equivalent to A implies the contradiction, and it goes both ways. So I got to not P, which is what I want to derive, and now I can say P implies not P because I got to not P from my assumption P. So by the rule of implication introduction applied to my assumption number 1, I can get P implies not P, and I can cancel my assumption. So I have cancelled all my assumption. I arrived where I wanted to arrive, and therefore I'm done.